Hi guys, this is two sum problem, and basically the thing that's happening inside it is that we're given with two arguments inside the function two sum, right? The first argument is nums and the second argument is target. Now our task is to find sum of two numbers from the nums array such that they add up to be equal to target, right? So the target is also a number, and then we have to find two numbers from the nums array which add up to give this target sum, right? So this is our question, and basically what do we have to return? So we have to return the indices of these two numbers which we have found inside this nums array, right? So we have to return these two numbers. How are we going to return them? So we are going to return them in form of an array of size 2, right? 1D array of size 2. So okay, so one of the things that's written here is that you may assume that each input would have exactly one solution and you may not use the same element twice. So basically what they're saying is that if suppose in the input array, if 6 and 6 is given once and you have to find a target of 12, so you cannot use the same number again and again. You cannot say that 6 plus 6 is 12, so that cannot happen. Wherein if 6 is present at two different locations, then 6 plus 6 is also equals to 12, which is fine, right? So basically you cannot use the same number twice, but if that number is present twice inside nums array, then it is fine, right? So you can see example number 1 with wherein we are given with nums array which contain 2, 7, 11 and 15 and a target of 9. So our task is to find two such numbers which when will be added will give this target of 9, right? So the output is 0 and 1, the index of such numbers. So basically when you'll add the number which is present on 0th index, that is 2, and at the first index, that is 7, when you'll add these two numbers, that is 2 plus 7, they'll give you the result of 9, which is basically true. And it's written over just above that exactly one solution will be surely there. So and we have to return only one solution, so exactly one solution is there and we have to return one solution. So this is our answer. The order doesn't matter. So here it is written that you can return the answer in any order. So the very first approach that we use is brute force. So what you can do is that you can just pause the video here and we'll start with the brute force algorithm first, right? So you can try it yourself also, or you can try eventually a bit later when you understand that how brute force works. So you can implement it by yourself and you can cross check it with my solution afterwards, right? So let us start. So first of all, let's consider a small array here. So this is our array, right? And we are having certain elements here. So suppose 2, 8, 7, 9, 6 and 4. Some of these numbers are present inside this array called nums, and the target of 9 is there. So we need to find out a target of 9, right? We have to add two numbers such that nums I plus nums j is equals to 9. If this case satisfies, then we have to return an array which will contain these two indices that are I and j, right? So the very first approach which we are saying is brute force, of course. How do we implement this? So basically what you're going to do in this approach is that you're going to set two pointers. So the first pointer is going to be a ith pointer and the second pointer is going to be a jth pointer, right? So in brute force, basically we are going to try for all the pairs, right? So we are going to try for 2, 8, then 2, 9, then 2, 7, 2, 6, 2, 4, right? Similarly, then afterwards we have to try for 8, 9, 8, 7, 8, 6, 8, 2, right? Then we can start with 9. So with 9 we have to say that 9, 7, 9, 6, 9, 2, right? Similarly with 7, 7, 6 and 7, 2. Why are we not doing the same thing for the numbers at the left hand side? Because we have already done the pairing, right? When we have started with the 2, we have already done all such pairs which are present in the left. So that is why we are just moving in the forward direction, right? We don't have to cover these elements again because we have done that, right? For example, if you want to see that what I'm saying, I can just give you a brief introduction about it. For example, 2, 8 is already done, right? When we were doing it for 2, right? I was present at the 0th location. At that time we had considered 2, 8 pair, then 2, 9 wala pair, then 2, 7 wala pair. We have tried these all. Now when we are here at 8th, right, at number 8. At this time, if we'll move to the left, if we'll start pairing from the very zeroth location, what will happen? Again, you are saying that 8 2 you want to try, but that's already done, right? For 2 8 is already done, because we just have to consider the sum of these two numbers, so it's not required to do at the to go to the left direction, huh? So we'll just move in the right direction, right? So this is what you're going to do. And if you want to see that how it works with ith and jth pointers, it's a very simple algorithm, brute force, which is the first loop is going to start from 0 and it has to go up till nums dot length minus 1, right, minus 2 and I plus plus, right? And the second loop, that is for j, is going to start from I plus 1 every time, right? We have to just check for the right hand direction, right? And j should be less than equals to nums dot length minus 1 and j plus plus. So what does these two loops means? It is basically saying that for I equals to 0, you have to try for j, you have to add I equals to 0 with j equals to 1 2 3 4 and 5, right? Similarly, for I equals to 1, you have to start j from 2 3 4 and 5, right? For I equals to 2, you have to start j from 3 4 and 5. For I equals to 3, it should be j equals to 4 and 5, and for I equals to 4, you have to start with j equals to 5, and that's it, right? So j is going until the last index, wherein I will stop at the second last index only, because if I is here, there is no possible value for j, right? So we should not try this I, because there is no meaning of this particular thing. So this is a brute force algorithm, right? So now what you're going to do is that we have to try for each of the pair, and we have to compare it with the target. If any time the sum is equals to the target, then we can stop our search there, and we can return the indices. But this algorithm would be of time complexity n square, right? So the time complexity is big of n square, which is like a little heavy process for large amount of n values. So we'll see some shorter solutions also, but before that, let's implement this one. So while implementing it, it will be very simple to implement this. What we're going to do is that we're going to have these two for loops. So for int I is equals to 0, I less than nums dot length minus 2 less than equals to, and then I plus plus, right? Similarly, we'll have a j loop. So here int j is equals to I plus 1, j less than nums dot length and j plus plus, right? And afterwards we have to check for the sum. So int sum, initially we'll keep it as basically we don't need an extra variable, so we can just check it here, that if at any moment nums I plus nums j is equals to the target, then what can we return from here? So we can return a new array, so new int of size 2, wherein the first index will be I and second will be j. If this condition never satisfies, which is not going to be the case in our question, because it is written that there is going to be exactly one solution present, so we can return null. So this is not the case that will happen ever, but of course, because of the syntax, we have to write it here, that is return, that something is returned every time, right? So let's submit it and let's find out the result of this question for brute force algorithm. So it's running fine, but of course with a runtime of 90 milliseconds, which is quite, it is showing that it is a heavier process. So we'll change this to a next basically approach. Let us see that too. So let's rub it out first of all. So we're going to start with the next algorithm, which will take a time complexity of big O of n, right? So in linear time it will be solved. So how are we going to solve it? It's going to be a very simple process, of course. So let's see. So we're going to maintain a key value pair here, right? So key value pair has to be maintained. So the keys are going to be the numbers itself present inside this nums array, wherein the value is going to be the index, right? So the logic is very simple, right? So while discussing the approach, you'll get to know the logic also. So it's quite simple. What you're going to do is that we have to iterate through this nums array once, right? So big O of n is the time complexity for this particular approach. So we started with I equals to 0. So right now our pointer is on 0th location. Herein we'll check that if target is equals to 9, right? So here we'll check that does our key value pair, does there exist any key basically with the value 7. So how are we checking for 7? Because right now at I equals to 0, num is equals to 2, right? We have this number 2. So we are saying that 9 minus 2 is 7. If 7 is there inside our key value pair, it means that there is an element already present, that is 7, and we are right now at 2. We have got this 2. It means this target can be formed, right? So 7 is of course there inside our array, but the problem is that inside our key value pair it is still not there, right? So if it is not there still, what we can do is that we can just add these key values. So 2 will be the key and the value would be the index, that is 0. So whenever we'll come to 7, we'll already know that 2 is present there, right? So for 2 right now we cannot form this target, but maybe later we'll have this target formed. So let us see. Let us iterate to the next position, that is 1. And right now we'll say that right now num is equals to 8 and target is equals to 9. So is there any number which is 9 minus 8 equals to 1? Is 1 present inside this key value pair? And of course 1 is not present. Okay, so we'll iterate to the next number, and of course we'll add 8 also. So 8 is at index 1, right? Then we'll iterate to the next position, that is I equals to 2, and here the number is equals to 9. Now 9 target is formed, but we want a 0 inside this key value pair, then only this target will be considered, because of course we want sum of two numbers to be equal to target, right? So is 0 there? Of course 0 is not there, right? If 0 is not there, then we'll not consider this, but we can add 9 to this key value pair wherein the value would be 2, right? We'll iterate to the next number, that is I equals to 3. At I equals to 3, now we are searching for 2 basically, because num is equals to 7 and target minus 7 is equals to 2. So we are saying, so we are looking for 2 inside this key value pair, and here 2 is definitely present. So we are saying that yes, we have found a number. So now what we can do is that we can return the index on which we are currently present, right? Because that is where 7 is present, right? So first index would be the same index on which we are iterating, and the second index we can get from the key value pair. So because we wanted that 2 should be there, and 2 is definitely there. So what we can do is that we'll say that okay, 2 is there and the index on which it is present inside this original array is 0. So 0 is the second index, right? And this is the array which we can return from here, and we can terminate the process here on. So this is what we're going to do in this question, right? So let's try for it. So again, what we're going to do is that first of all we'll need a map, right, in which the key is going to be of type integer and the value is also going to be of type integer, and let's name the map to be map, right? And let's initialize it, let's instantiate it. Okay, and it is done. And now what you can do is that we can, because we need to traverse through the whole array once at least, so, or maybe at most, not at least. So int I is equals to 0, I less than nums.length and I plus plus, right? Maybe we'll terminate the process in between also, so that we'll see. So right now we are saying that if, so first of all the first element is of course nums I 0. So we are checking for key, right? So map dot contains key. Which key? So we are checking for target minus nums I, right? We are saying is this difference of target minus nums I is present inside our map or not. If it is present, right, if this is the case that the key is definitely present, then what we can do is that we can return the two indices, right? The first index will be I itself, so return new int in which the first index will be I itself and the second index will be map dot get. So basically we want the value where nums is present, right? The value is index itself. So we are saying that just get this index wherein this value is present, if this is the case, of course, right? If this is not the case, that is the key is not present inside the map, right? So then what we have to do is we have to simply add this particular number into our map, right? So we'll put, so map dot put, the first key will be the nums I and value will be the index on which it is present, that is I. And this is how this question is completed, and that's it. Return null, otherwise, right? Will not reach at this place ever in the program because it's already written that exactly one solution is present. So at any point of the time, at any point in time, we'll definitely get to this particular statement, return new. But for programming sake, for language sake, for the syntax sake, basically we have to write this line of return null, right? So let's now check for the output. Okay, there's some error inside this particular declaration, so let's solve that first. So the only thing that I can see right now is that we have to add this new also. So let's run the program now. Let's check for any other error, if any. So again, there is some bracket error. Let's put it here. So we are running the results, and again some problem has occurred. What is it? That contains key is not present. Okay, the spelling mistake. Okay, all the three cases are running. Let's submit the code. And it is the very first problem that lead code has. Right, so right now the runtime is of 1 millisecond. So we have improved our algorithm a lot, right? So let's see you in the next video. If you like the video, please do like, subscribe, and thank you so much.